So today we're moving on to 1.5, investments involving regular payments. So we'll start with the Explore. Andrew's been depositing $200 into a savings account at the end of every month. The investment rate on her, so apparently Andrew's a girl, on her minimum monthly balance is 6%, compounded monthly. He now has between $1,000 and $1,500. How long has he been depositing money into the account? So you'll make a chart similar to this one. So at the start of month 0, he has $0, 0 interest, but then he deposits $200, so he ends that month with $200. Then at the start of the next month, he already has $200 in his account, and we can calculate the interest on that. So the interest is 1. Then he's going to deposit another $200. So how much does he have at the end of that month? No, 401. Good, because he put another 200 in. So now at the start of the next month, he's got 401. Again, we're going to times by our interest, which is 401 times 0.06 divided by 12, because again, interest compounded monthly. And that should give you $2.005, but he's going to deposit another 200. And so how much does he have now? 603.005. So please continue this chart and we'll see when his end result is between 1,000 and 1,500. So notes, investments made with regular payments are sometimes referred to as annuities, likely because at one time these investments always involved annual payments. We'll focus on simple annuities, which have the same compounding frequency as payment frequency, i.e. both compounding and payment frequency are monthly. Ordinary annuities have the payments made at the end of each pay period, and the timeline begins at 0. Many familiar investments are annuities because they involve regular deductions or withdrawals from paychecks or bank accounts into investment accounts. Example 1. Trayton is saving for a trip to Australia in 5 years. So time is 5 years. He plans to work on a student visa while he's there, so he only needs enough money for a return flight and his expenses until he finds a job. He deposits $500 into a savings account. At the end of each 6-month period, he earns as a waiter. The account earns 3.6% semi-annually, so notice that 6-month period is when he deposits and semi-annually, so they're the same. How much money will be in the account at the end of 5 years? So the first step would be to write down your formula. So A equals R times 1 plus R over N to the power of N times T minus 1 all over R over N. And this whole thing would be in brackets because we times it by R. Now here, R is the payment per month. And we're trying to find A, we're trying to find the future value. So we'll plug in everything we know. He puts in $500 per month. We know that his rate is 3.6%, and it's compounded semi-annually, which is twice a year. And he's doing this for 5 years. Divided by the rate, which is 0.036 over 2. So when we're doing this, we just follow BEDMAS. We start with the inner brackets. So we've got 0.036 divided by 2 plus 1. So 500 times 1.018 to the power of 10 minus 1 all over 0.018. Then next is exponents. So 1.018 to the power of 10. So which is 1.195 minus 1 divided by 0.018. So then we have 500 times, when you figure that all out, So the future value is 5,425, and that's how much money will be in his account. Now, if I asked you how much interest he actually earned, how could you figure that out? Nope. We know how much did he put in altogether? Okay. Let's figure out how much he put in total. So he put in 500 twice a year for 5 years, which means in all he put in $5,000. So the difference between his principal, or how much he put in, and how much he ended up with is your interest. So your interest is actually going to be $425. So next up we have example 2. Let's compare regular payment with a single payment investment. So we've got Adam, who made a $200 payment at the end of each year into an investment that earned 5% compounded annually. Then we have Blake, who made a single investment at 5% compounded annually. At the end of 5 years, their future values were equal. What was their future value? So we're just going to use our formula, and then we'll plug everything that we know into it. And you should end up with a future value of $1,105.13. Part B, what principal amount did Blake invest 5 years ago? So remember that Blake was just doing a regular compound interest, investing one amount. So we know that his future value was $1,105.13. Principal is what we're looking for. He did a 5% interest rate compounded annually, and the time he did was 5 years. So we're trying to figure out his original amount that he invested or his principal. So you should have got your principal to be about $865.90 or about $866. So now we need to figure out which was the better investment, who earned more interest. So let's take a look here at Adam. He put $200 in per year for 5 years. So that means he invested a total of $1,000. So the interest he made was $1,105.13 minus 1,000. So he made a total interest of $105.13. Whereas Blake had $1,105.13 minus his principal of $865.90 to get a total interest of $239.23. So you can tell that Blake definitely had the better investment. The reason for that is because he had a larger sum of money in for more time. Even though at the end here, they ended up in the same amount, Blake had more money in at the beginning. Okay, so that earned him that extra interest right from the start. So example 3, this one we're only going to set up the question. We're not actually going to solve for it, and I'll show you why in a minute. CeeLo deposits $750 into an investment account at the end of every 3 months. So every 3 months, what compounding period is that? Quarterly. Okay. Interest is compounded quarterly, and the term is 3 years. The future value is $10,059.07. What is the annual rate of interest? So R is what we're looking for. So let's plug this into our formula. We get the future value is $10,059.07. Monthly payments are $750. Interest is what we're looking for, compounded quarterly. And the time is 3 years.